Hi everyone, welcome to the next session, design and drawing of reinforced concrete structure. Up to now we have discussed about the various type of loading conditions as well as we have discussed about the design code books. Already we have seen about the how loads are coming on the building. We have seen about dead load, live load, wind load, seismic load, as well as we have discussed about the assumptions for working stress method. Based on assumptions, now we will see the how our regular buildings beams will be designed. We will see here. If you see here, this is one simply supported rectangular beam. You are having the width of beam as B, and where D is the total depth of the beam. If you observe here, reinforced concrete means the concrete steel we are embedding into the concrete to enhance the tensile strength and the compressive strength. That concrete, it will be called as a reinforced concrete. If you see here, these are the steel bars were introduced in the bottom zone of the concrete to resist the tensile stresses. Why? Because concrete will take care of the compressive loads, but it cannot resist the tensile loads. Hence why we are introducing the steel bars in bottom of the concrete member. Again, if you see here, this is the middle axis. It will be called as a neutral axis. Neutral axis will divide the concrete into two phases. That means compression phase as well as tensile phase. Compression phase means the concrete will take care of the compressive loads. Whereas in tension phase, the structural member will take care of the tensile loads. That means here we are embedding the steel. Steel will take care of the tensile load. And if you observe here, this is the assumption. That means plane section remains plane before and after bending. Already we are discussing in working stress method. Same assumption also we are going to discuss in limit state method of collapse under flexible condition. In those conditions we will see very clearly. If you observe here, this is the maximum compressive strain in concrete. It will be taken as 0.0035. That means if you take any structural concrete member and I am applying the load, due to the application of the load, the maximum compressive strain it will be taken as 0.0035 for concrete. How it is coming, we will see. Again, if you take the maximum tensile strain in the steel, if you observe here, the maximum tensile strain in the steel we are taking as 0.002 plus 0.87 into Fy by Es, where Fy is the yield strength of the steel, where Es is the modulus of elasticity of the steel. Elasticity means resistance to deformation. That means if you apply the load, due to this load condition, the member will may elongate. Again, if you remove the load, the member will regain its original position. If you apply the load, member will deform, and if you remove the load, material will get regain its original position. That material will be called it as a elastic material. This is the strain diagram for both concrete and steel. If you observe here, this is the stress diagram for both concrete and steel. If you observe here, this triangular portion is the compression forces acting on the structural member such as a concrete beam. I am taking this concrete beam and I am applying the load. Due to this application of the load, the strain variation is acting in this direction. That means in the triangular portion. If you observe here, this is the total compressive force acting on the concrete beam, where C equal to half into FCK into Bx, where B is the width of the beam, FCK is the characteristic strength of the beam, and X is the depth of the concrete beam. These terms we will discuss deeply into the limit state method of collapse. Again, if you see here, this is the tensile strength of the concrete, that equal to 0.87 into Fy already we have discussed, where Fy is the yield strength of the steel. This is the diagrammatic representation for working stress method. The same method we will discuss in a limit state of method of collapse under flexible condition. And if you see here we are discussing the one more column, neutral axis. Here we will discuss what is meant by neutral axis. First see the definition. Neutral axis lies at the center of gravity of the section. It is defined as the axis at which the stresses are zero. That means if you take this concrete beam, due to application of the load, compressive force are acting as well as tangential loads are acting. At some phase, the concrete, it won't take any compressive forces, any tangential forces. That distance it will be called as a neutral axis. Otherwise, neutral axis divides the section into tension and compression zone. If you see here, this is the concrete beam. Already we have seen the above the neutral axis. This is the compression phase. That means it will take care the load by concrete, and below this neutral axis, this is the tangential zone. That means this load what you are getting on the concrete beam, it will be taken care by the steel bars. And if you observe here, where from neutral axis to top of the compression fiber, we are taking it as N. Already we are discussed about the effective depth. Effective depth means the concrete structural member you are providing from the top of the compression fiber to the some certain depth. That means up to this depth. That depth it will be called as a effective depth. After effective depth also we are providing concrete. Why? Because if you are not providing the concrete below the tension zone, the steel will get exposed to the environment and corrosion of the steel will may happen, structure will collapse. Hence why after effective depth also the concrete we are providing. That effective clear cover we will discuss in later classes. If you see here, this is the stress strain diagram for compression zone as well as both in tension zone. If you observe here, in this portion the concrete is take carrying the compressive force. The compressive force is represented here as sigma C. Again, if you see here in this diagram, the concrete will not take care of any type of tangential loads. Only steel will take care of the tangential loads. The tangential loads it will be represented by the stress of steel. That means sigma S. This is the diagrammatic representation for neutral axis. If you see the neutral axis constant, it will be represented by the symbol K, where K equal to M into sigma CBC divided by M into sigma CBC plus sigma ST. Already M we have discussed. M it is defined as the modular ratio stress in steel to the stress in concrete, where sigma CBC is the permissible compressive stress in concrete, and sigma ST is the tensile strength of the steel or tangential stresses in the steel. These are the terms for working stress method for under singly reinforced section. The same terminology deeply we are discussing limit state method of collapse under flexural condition. And if you observe here we are introducing one more term called lever arm. Lever arm is the distance between the resultant compressive forces and the resultant tangential forces. That means if you observe here, in this direction up to neutral axis, the compressive forces are acting, and from neutral axis to some depth again the tangential forces are acting. That means some phase it differentiates in the both compression forces as well as tangential forces. That compression forces and tangential forces difference we are representing by using a term called as lever arm. You see here, lever arm is the distance between the resultant of compressive force and the resultant of tangential force. For this lever arm, we are using the formula J equal to 1 minus K by 3, where J is the lever arm distance from compression of the fiber to the some neutral axis depth, and where K is the neutral axis constant, and 3 is the value of empirical value we will discuss in limit state of collapse. And see, next one is the moment of resistance. Moment means force into perpendicular distance. That means for any member, due to this application of the load, some movement it will may happen. That means due to this force, the structural member will may move that some certain side. That side will be represented by the moment of resistance. If you observe here, moment of resistance is the resistance offered by the beam against external loads. As there is no resultant forces acting on the beam and section is in a equilibrium condition. Suppose that means here I am taking some simply supported beam and I am applying the some external load. Due to this external load, the member will may exert some external forces. Due to this external forces, the beam may apply the some moment. That moment it will be called as a moment of resistance. If you see here, compressive force is equal to the tensile forces. When compressive forces is equal to the tensile forces, the beam will be in a equilibrium position. If compression force and tensile force are both not equal, the member will may get move. If you see here, these two forces, that means equal and opposite forces by perpendicular distance, the compressive forces and external forces both forming like a couple. That means already we are discussed. If you observe here in stress strain diagram, the compressive force is acting in this direction and the tensile strain is acting in this direction. Both opposite direction the forces are acting. Due to this opposing forces, it forms a couple. That couple will give the moment of resistance. This moment of resistance also how we are calculating, we will see in our subsequent lectures. And next we are having the different type of sectional members for designing any concrete member. If you take our structural design, the beams are classified as singly reinforced beam, doubly reinforced beam. And again, if you take the based on the loading condition, we are having simply supported, uniform, simply supported beam, cantilever beam, fixed beam, overhanging beam. Based on the supporting conditions, we are dividing the beams. As well as based on design conditions also, we are dividing the beams. That beams, it will be called as a balanced section, under reinforced section, and over reinforced section. Here we will see what is meant by balanced section, what is meant by under reinforced section or under reinforced beam, or what is meant by over reinforced beam. First we will discuss about the balanced section. For this balanced section, what I am doing means, first I am preparing the concrete. After preparation of this concrete, I am making a simply supported beam, some concrete rectangular beam, as well as I am inserting some steel rods in the tension zone to enhance the compressive strength as well as tensile strength. If you see here, reinforced concrete beam section in which the tension steel also reach yield strain simultaneously as the concrete reaches the failure strain in the bending are called balanced section. Suppose here this is the rectangular beam. In this rectangular beam, I am applying the load. While applying the load, the steel also will get simultaneously along with the concrete. Steel also will get failure along with the concrete. Steel also failuring along with the concrete. That means this section will make it failure. If the failure of this section along with steel and concrete both at a time, that section it will be called as a balanced section. If you observe here in this diagram, we have prepared the concrete beam and we have inserted some steel rods or steel bars, and I am applying the load. Due to this application of the load, the tensile strength of the steel is reducing, the steel failuring as well as concrete also get failuring. Both these conditions, both the materials are failuring at a same condition, same time. That same time condition failure, it will be called as a balanced beam section. And next we are having the under reinforced beam section. Here what is meant by under reinforced section we will discuss. See here, reinforced concrete beam section in which the steel reaches yield strain at the loads lower than the load at which the concrete reduces failure strain are called as a under reinforced section. Now first I will show this diagram. If you observe here, this is also one simply supported rectangular beam. Here also same, I am introducing the steel into the concrete to enhance the compressive strength and the tensile strength. In this diagram, if you observe here, before failure of the concrete, the tensile steel will may get failure. Due to failure of steel having ductility property, due to this ductility property, immediately failure of the concrete beam, it won't occur. That means if you take the structural member concrete in steel under reinforced section, if you apply the load, due to this application of loading on the member, steel will get failure first and concrete will get failure later. Steel having the ductility property, due to this ductility property, steel concrete member will failure slowly. It gives the alarm. Due to this alarm condition, we can slowly get out of from the building. This is the advantage of under reinforced section. All major type of structures, any other type of structures will be designed only based on the under reinforced section. The failure in under reinforced beam section due to the concrete reaching its ultimate failure strain of 0.0035 before steel reaches its failure strain, which is much higher than 0.00025. That means steel also will get failure, concrete also will get failure. First failure will come in steel, hence steel having the ductility property. Due to this ductility property, immediately the structure will may not collapse. Okay, hence why we are introducing the design of steel for different types of structural members. Next we will see the over reinforced section. Here if you observe here, this is the concrete beam. Again in this concrete beam also we are introducing the steel in the tension zone. In tension zone also concrete beam again, and I am applying the load. Due to this application of the load, what it will happen means concrete will failure first. Later the steel will may get failure. Due to immediately failure of the concrete member, the building may collapse. That means strains will come into the concrete first. Later the strains will come into the steel. Hence why concrete is a brittle material. Concrete will immediately get failure. Due to this immediate failure, the structure may get failure and it leads to the loss of life and property. If you see the definition, reinforced concrete beam section in which the failure strain in concrete is reached earlier than the yield strain of the steel reached. That means before failuring of the steel, the strains in the concrete is getting first. Due to the strain in concrete getting first, the concrete is a brittle material. Due to this brittleness of the concrete material, the member will may get failure. Hence why many structural designers, they compulsory told that we should not to design the beam under over reinforced section. You can design based on the balanced section or under reinforced section. Okay, again one more time briefly I am discuss about this. What is meant by balanced section, what is meant by under reinforced section, and what is meant by over reinforced section. If you take the balanced section, in balanced section both steel and concrete simultaneously will failure at a particular time. That member what you are designing will be called as a balanced section. In the same way, the steel will get failure first, later strain will come in concrete. If you design the beam in such a way, that beam it will be called as a under reinforced section. In under reinforced section, steel getting failure first, later the failure zone is coming to the concrete. Okay, hence if you design a beam in such a way that members will be called as a under reinforced section. All type of structural members we have to design based on balanced section or under reinforced section. And last one is the over reinforced section. In over reinforced section, the load what you are getting on the concrete member, first it will be taken care by the concrete. That means concrete strain will get first, later the strain will distribute to the steel. Concrete getting strained first, hence why concrete is a brittle material. Concrete will failure very fastly. Hence why we are not design any type of structural member for the over reinforced section. How we are designing, how we can say that what is meant by balanced section, what is meant by over reinforced section, what is meant by under reinforced section, based on design conditions, we will see in our subsequent lectures. Okay. Now we will see the conclusions. Up to now what we have discussed. We have discussed about the working stress method. We have discussed about the design of a structural member, how we are designing based on the compressive forces and tangential forces, as well as we have discussed about the neutral axis. Neutral axis, it divides the section into compression zone as well as tension zone, as well as we have discussed about the lever arm. Lever arm is the distance between the resultant of compressive forces as well as resultant of tangential forces. And we have discussed about the moment of resistance. In moment of resistance, due to equal and opposite forces, it forms a couple. Due to this couple, the moment it will may generate in the beam due to the external loading condition. Based on this moment, how we have to design the structural members also will discuss, as well as we have discussed about the what is meant by balanced beam section, what is meant by under reinforced section, and what is meant by over reinforced section. In later class, we will discuss about the limit state of method of collapse under flexural condition. Thank you.